would have been considered a conservation tillage, but it's been tilled already this year one time, so it didn't have the residue to classify it as it would have been considered just regular tillage. But we're going to add water to that one, and we're going to add water to this one. This one hasn't been planted, but this one actually has been planted already. This is a no-till for the last 15 years, and it's a cover crops for the last 4 years. Woo-woo! And so we're going to compare what the difference is. These trays are slightly slanted. They'll either run off the top and go into the front tray, or they will infiltrate and drop into the second tray. And we'll compare these trays afterwards. So let's go ahead and start with conventional tillage. Actually, we'll do both of them together. That's more exciting. I hope I don't run over.
Yeah, did you?
I did measure it. This one, and I want to, really, this was kind of a discovery in itself. It did all run over the front. And this one's really soaking up. There was a little bit that ran off it, but it was basically because of the slope. If this went longer, and I can continue to add a little bit of water to this, because it was just a question that it had to, it all came to the front, but it has to soak through, and it will continue to drip. This one won't drip at all. If I took this soil and took it off and was outside and flipped it over, you would find out that about that far down in the soil it is completely dry. It completely seals over so it can't go in. Where this one actually has wormholes, it has decayed residue, so there's channels for this to go through. This one is forced to run off. When it rains, virtually no chance for the infiltration of a rain event of even a quarter of an inch. It literally just hits, ponds across the top, and runs off, and this is what you end up with. Where this one, it did run off a little bit, but look how much clearer it is. But on a normal rain event, on a normal field in Illinois, as small as that rain event would have been, it wouldn't have probably even ran off. It would have all soaked in. But you still have clear when it's soaked in.
So say the difference again.
This is conventional tillage. This is no-till with cover crop. So it has soil health. That's the difference. This one, what happens is, and also, you build up organic matter. And so there's another test you can do, the slate test, where you actually drop 2 pieces of soil into a jar or a water, just a container of water. When you drop a piece of this into it, it immediately just dissolves and drops to the bottom. But if you drop this one into that same situation, it just sits there holding together. So all the organisms, all the living entities actually create a glue that holds the soil together. So this is soil without health. This is soil with a good start on soil health. So from there we move to, and the problem with this is we're not feeding the soil between after harvest until we plant. So it just sits there with no food for the organisms. That's a big part of this whole situation. Now these are winter wheats. This is a winter wheat. So it actually grew all winter. So there is some biologicals to this that help to create, it's a larger rotation. So you have corn, beans, we're adding wheat. And you can add a lot more. This actually has wheat, but it also has red clover already in it. So I'm planting wheat, and then I come back in the spring and interseed, frost seed red clover. So when I harvest the wheat, there's no separation between growth. When I harvest, this will already have red clover about that tall. So that if an event happened to come along at that time, I'm already protected with living organisms. But let's look at these last two. This is the history. This is the modern history, or this is the history in the making. This is Kernza. This is a perennial wheat as opposed to an annual wheat. This would be compared to, Kernza would be more compared to, and it is a wheat, but I would compare it more to a prairie type grass. Not that it is a warm season grass, but it has the same root mass. It literally grows 10 feet deep in the soil. What also it does is becomes a prairie type soil. So when I put annual wheat out, it gets about 6 inches at the most, a foot deep. But really 6 inches is where the mass is at. This literally creates a mat of grass, of roots. So when it actually, any extreme, whether it's heat or extreme of drought or extreme of floods, it becomes either a sponge or protects the soil from a drought. So this will still do good in a drought, still do good in a flood. So every situation it's protected. So that's the problem with our system now. There are always going to be times when the flood or the rain or the drought comes at the wrong time. Well, sustainability needs to be 12 months out of the year. So let's hope this works. And I really don't, this is all about infiltration. Let me just make sure that's on there. Sorry about that. And I think because it is sloped, you're still going to get some, but I'm going to hold it up when we get done.
What are the uses for that wheat right there?
Bread, beer, distilled, yeah, all the good things. Pastries. Supposedly it's a lot. The real surprise was pancakes. It has such a nutty flavor to it that in pancakes it's really like a huge difference. So pastries,
Grazing.
grazing, it's also to get it to yield to its maximum potential, it's better to graze it in the spring, stop grazing it, or bale it in the spring and then let it grow back, and it gets its best yield after that.
Okay.
And it's a higher level. They have an index that measures the nutritional value of hay. It's higher than alfalfa, which is
So any animal, I mean livestock, could make.
any livestock. Yes. And another great thing, great, not so great, Kernza's gluten is different than wheat's gluten. It's less allergy, but also part of that allergy comes from the fact of I don't know what the word is, to make it all stick together to rise.
Right.
The Kernza gluten isn't the same level of gluten. You really need to mix it to make your bread stick together and rise. So
But for animals,
for animals, the grain's not even, we wouldn't use the grain. The grain's just
I mean, for that, I can.
for this,
Interesting.
that is amazing that it's actually a greater value than
Sure.
than
The
alfalfa.
which
Yes, we are using
likes
that.
to get.
If I had wheat, right now when I have wheat and Kernza growing side by side, every night the deer are in the Kernza and not the wheat.
Really?
They prefer the Kernza over the wheat.
Huh.
I heard. Yeah, well, about 20. They fluctuate depending on the season.
Was the wheat actually tilled or?
This week's no-till. So it has good advantages, but I mean that's pretty crystal clear compared to a little bit of And I think part of this too, running off the front, this one I had to kind of watch when I it's hard to go through a prairie because it's such deep rooted and mad. It just was hard for me. I thought for sure I was going to bend this trying to get it through. But then when I did, it shrinks and expands, those root systems. And I went over to Jack Erzman, some of you guys might know Jack. He wanted to look at the root mass, and I said, oh sure, I'll come over and help you, Jack. And he said, well, I got about 3 hours, let's do it. And I said, but I had a meeting. I said, well, I'll come over, we'll get it done. We tried to get down as deep as we could. We got maybe 3 feet, 3.5 feet, but it goes 10. We just had 2 tree spades. We got 3 feet out, and turned it over. Was no feet to do that, but then we started pulling the dirt off of it, and it really held the mat together. But it got to the point after about 6 inches and still have 2.5 to 3 feet to go, we couldn't get the soil out of the roots. It was so it was just so encased in the roots. There was, if you can't use a knife, and we had a knife and a screwdriver, we couldn't get it out of the roots. So think how good that holds on to the soil, but also how well it protects the soil. It literally holds on to the soil. So it's a living thing that's protecting the soil. So I really feel like this is agriculture, and this is more nature agriculture. I think this is more natural, more in tune with a natural system. And I think at some point in time, if we'd have put our energies into perennials back when we put them into annuals, we wouldn't be in the situation right now we were in. So this is a lot of research is going into this now, and I think this is something we're going to see. They also have sorghum, they also have perennial sorghum, perennial rice. They just hired a breeder to breed perennial legumes, which will be peas and beans, and they've developed through the University of Kansas, University of a few other places that I can't remember, Bio-Gnome Agricultural Engineering PhD potential. I mean, it's going to be a whole coursework where you can get a degree in Bio-Gnome Engineering for Agriculture to look at prairie agriculture. So it's exciting. So it actually worked, I feel.